In this video, we're going to try another practice problem where we have to identify functional groups and say what family the molecule would be part of if it did have those functional groups. Now, keep in mind, this molecule here has many functional groups that we're looking at. So it's a bit more difficult to classify this molecule as part of a certain family. There are things called priorities, and the priority of a functional group would determine, if we consider that one before others. We don't need to know that right now. We'll focus on that later. Right now, let's just identify functional groups. So I'll start with A. A is a pretty straightforward one. We have an OH with a carbon and a double bond O. Remember these points here, they're considered carbons and also hydrogen groups if you can put them there. But we have a C double bond O OH. So C double bond O OH. And then there's a carbon chain like the rest of the whole thing. Let's just call it an R group, a carbon chain of some sort. This here would be a carboxyl group, and that would make you a carboxylic acid if you only had the carboxyl group. Okay, let's go to B next. Right here, it's already circled for us. B is the amino group, and that would make you an amine if you only had the amino group. C, we have the C double bond O. And so that would be a carbonyl group. And, let's fix that, carbonyl group. And that would make you in this case, because it's in the middle of the molecule somewhere, it's a ketone. So it's acting as a ketone. Let's go to D. D over here looks like a carboxyl group at first glance, but then there's a little point over here, and that's a carbon group. So we have a carboxyl group connecting a carbon group here, and then on this side technically as well. So that means this would be carboxyl again, but in this situation, it would make you an ester because you have carbon chains on both sides. Now, E is one of those 6 carbon rings with the alternating double bonds there. So that makes this a benzene functional group molecule, and that would make you an aromatic hydrocarbon if you only had that benzene there. So we have carboxyl group, carboxylic acid. We have amino group, amine. We have carbonyl group, making it a ketone. We have carboxyl group, making an ester. And we have the benzene ring, making an aromatic hydrocarbon. Again, we don't know what the whole molecule is, like I said, because we don't know the priorities yet, but we'll come to that later on. Here we have another molecule. You can do the same exercise. As usual, I recommend you pause the video first, and then after you pause the video and try it yourself, you can unpause and then give yourself some feedback. So let's try some of this out. So we'll start on this end here. Nice, easy one to identify, OH. That would be our hydroxyl group, which would make an alcohol if it was your only functional group there. So it is acting as an alcohol. Here we have the O and then a carbon chain on both sides. And so if you look at this over here, that's an interesting one. We didn't see that one for a while. That would be our ether, just to show you what the ether looks like. It's our ROR. And the carbon chains, so there's 2 carbon chains. This one here is R prime. That means that it could be the same carbon chain, but it could also be just a different carbon chain. It doesn't have to be the same length. And so it's an alkoxy group, making an ether. You could identify this one over here as well as a benzene ring, making an aromatic hydrocarbon. Keep in mind this molecule itself is not a hydrocarbon because hydrocarbon is really only carbon and H's. Look, we have an N over here, but be careful. The carbon right next to it has a double bond O. So we have a C double bond O with an N. So that's C double bond O, N, and then there's H and carbon chain, but you have this part here. This makes the carboxamide, which would make an amide. Okay, we have this over here, this double bond, right? That's a C double bond. That would make an alkene. So the functional group is a C double bond, which would make an alkene, not alkane or alkyne. Alkene is the one with the double bond. So what we just did in this video is we took a look at some big molecules. A lot of the molecules that are active in our body and that we use for medications are often big molecules like this with many functional groups. The functional groups have a variety of different purposes to allow them to the drug or the molecule to interact as it's intended to. And so it's important for you to be able to identify those functional groups and name what they are within any molecule.